Hi, I'm Derek, and in this video we're going to have a look at an algorithm that I use extensively in XDebug and is also used by PHP quite a lot, which is something called reference counting. Let me show you what I mean by that. So in example for XDebug, when I have a breakpoint, I need to store the breakpoint sometimes with different keys. So an algorithm that I have is called a hash table, where I have a name of something, or rather a key that I've created, which is, for example, file, and then say I need to remember from which line this belongs to, so I have a start and an end line, something like this, and this then maps to some information that I need to store, like the breakpoint information. And the breakpoint information contains like this bit of data here, where I need to remember that how often this first of all, whether the breakpoint is enabled, what type of breakpoint it is, whether it's a line breakpoint or whether, or maybe a better example is a entry or an exit breakpoints on functions, and then some other information here as well. Now, from these keys, this gets hashed. This whole key, this is like a string. And the hash of the string creates a number, say 84. The number is much longer, but it actually depends a little bit on how many elements I have. Again, this is not important. So in this hash table, then the table here will have entries from 0 all the way to, and then even further on. Now, that doesn't necessarily mean that each of these elements is filled in, but it could be or it could not be. Now, with this, sometimes I also need to have a different key pointing to this, so that is a totally different table. Now, of course, what I can do is I can create this other hash. Say I need to map it the other way around. And then I need to have a similar table. So what I can do is, of course, I can duplicate this information because these get inserted at the same time. So this is like a copy with the same elements. Let's fill in some information in there as well. And then this hashes to a different number and also in a totally different table. So here we go from the size of these hash tables is often a set amount, although there's some algorithm of doing that. In any case, anytime I need to do this, I now have these two data structures. And in this case, whether it's enabled or not will be 1 byte, whether it's exited entry is also 1 byte, and then the other information is actually quite a lot of data. So, for example, in my case, it is 46 or 48 bytes or something like that. Which means anytime I need to use a data element in 2 locations, I end up copying it. And of course, that takes up twice the amount of information here, which is of course not very efficient. So what you can actually do is do this in a different way. So let me copy the entries for the hash tables again on a different sheet, and then we'll see how we can do this better. Bear with me for a second while I copy this. So first what I'm doing is when I actually create the first element, I allocate this this data block that has the actual information here, right? So I have the enabled, the EX, and then some other bunch of data. So I will then store this in my table. That is the first step. Now in the second step, when I create the entry for my next table, so which has the other hash, as you remember, so in my previous example, I copied this whole data, but instead I'm not going to do that now. Instead, what I'm doing is I'm actually remembering how often it has been referred to. So the first time when I add it, I set a reference count, which is an extra field. It's called ref count. I turn that to 1, which means that the number 1 in the reference count means there's one data structure that points to this. So when I initialize this, I know for sure that there's one thing pointing to it, otherwise I wouldn't have to create it. Now then, when I need to use the same data structure again in my second hash table, so instead of copying the data, I will actually just point to it from here via an indirection here. Doesn't particularly matter. And then I will update this number to 2. So now there are 2 things associated with it. Which means that now when I destruct things, what I need to do is, instead of when I destruct the entry, I can also destruct the table. But because of this indirection knows there's 2 data elements in there. So the first time when I remove this key, it removes this table. Due to the indirection, instead of freeing up this memory, because the number is higher now, right? So anytime this needs to be freed, this number gets decreased by 1. And only when the number hits 0 does this get freed as well. So after the first destruction of this element, this still exists because the number drops from 2 to 1. But only if I then destruct this one through the indirection, it then drops the number to 0. And only then you end up freeing this item. So in this case, it isn't maybe that useful because there's only 2 pointers to it and it isn't that much data. But PHP uses this internally quite a lot for any sort of strings that you have or any sort of variables. When you do a variable assignment, it will not immediately copy the data associated, but it will increase its reference number. And this is actually a really quite efficient way of doing it. You save quite a bit of memory, but you also sort of need to take care of this indirection, which isn't that much of a problem because that's usually how these data structures are implemented to begin with, through pointers. So this is how we do reference counting. Hopefully you found this interesting. Let me know in the comments if you have further questions. Thank you for watching and I'll see you next time.